Welcome everybody to the 7 Steps to Better PHP Code Part 2. Actually, welcome back everybody. For those that have attended the first part that I held 2 weeks ago. Thanks again for Zend and Nili to host the whole thing and broadcast that throughout the internet. Well, my name still Stefan Priebsch. I'm from Munich in Germany. I do PHP since 2000, starting with 4.0 Beta 3, I believe. I'm an IT and PHP consultant. I have a university degree in computer science from the Munich Technical University, and some of you may know me. I do quite a lot of writing. I write books and articles, mostly about PHP. I also blog at insight.innovative.de, which is my company. And of course, if you have any questions or want to drop me a note, you are more than welcome to send me an email at any time. We will be talking about 7 steps to better PHP code, and this is the second part today. Basically, this is a talk about refactoring, as I've already mentioned last time. Just to get you up to speed again, what is refactoring? Refactoring is about changing code, and it's about changing code to improve the readability, to simplify the structure, to improve the design. You're not supposed to change the results, so you're not adding new functionality, you're not adding new features, you're improving existing code, and if you start adding new features, that's not refactoring anymore. Okay. Last week we had the question coming up about IDEs, so I've done a little bit of reading. Since this is a Zend presentation, I'll put in the shameless plug for Zend today. Zend has, I think it was this week, released their Zend Studio for Eclipse, and this has a refactoring support. You can move files and folders, and it helps you renaming stuff, and it helps you to organize includes, so that's maybe a good thing to look at if you want to get into refactoring. There's a URL where you can download, and I think you can also download a trial version there. By the way, if you have any questions, just use the Q&A panel. Type in the question there, and I will pick it up as I go. If any questions remain unanswered, then I will answer them using the Q&A log, and this is going to be posted along with the slides of this presentation at the Zend website, which takes us to the next slide. Last time we started off by the first 3 steps: formatting source code consistently, using consistent naming, and documenting the API. And we are going to look at 4 more steps today, and these are the steps dealing with the actual code, so we're going to look at a lot of code today. If you want to have another look at the first part, there's a URL there at zend.com resources webinar, where you can pick up the first part, the slides, the audio, and also the chat log with the answers I've provided you with. So, step number 4 is the first thing you should do when you start working on the code, is to eliminate redundant code. Redundant code is a very, very bad thing. You should always avoid duplicate code or similar code in your application. The basic idea of it is that if you change something in the application, you want to make the change in just one spot. You don't want to make the same change in 3, 5, or 7, or 10 places, in 8 different files, in whatever different locations, because you're very likely to forget at least one of them, or change one of them in an inconsistent way, so you have the application behave differently under certain circumstances, which is definitely not a good idea. So the basic idea of eliminating redundant code is you want to be able to make changes to the code by just changing it in one spot. It's not always possible to really get it down to one spot, but it's a very good idea to try to approach that. How you do that is by creating parameterized functions and methods, and as you will notice, I will be talking about procedural code, and I will not show OOP examples today, because I know that a lot of people out there do not use OOP extensively, and it's one of my goals to show you that the whole refactoring and the whole 7 steps I'll be presenting will work as well on, just as well on procedural code. You don't have to do OOP to benefit from all this and to benefit from refactoring. It makes it even easier, and you will soon get tempted to introduce OOP, I think, but it's not an absolute necessity. There's something missing. I realized in the last line. I'm sorry about that. Do not overgeneralize when programming. This means if you write code, and sometimes you try to think ahead. What changes will I have to make to that code tomorrow? In which ways will this code be used tomorrow? And you'll start and try to get that in, which is sort of ultimately leads you to, we have to create a really big framework before we actually can create business logic. And this is definitely a bad idea. All the agile methods say don't do this. Do not generalize. Just solve the problem. PHP is excellent in helping you just solving the problem, and you can use refactoring to get back to the point and change things if you need to change and extend them. But do not overgeneralize them up front, because you'll just waste a lot of time and resources. Usually you end up having code generalized for stuff that you won't need. And you will find yourself in trouble building in things that you need, and you haven't thought about that, so your code does not make that possible. All right, let's look at some code. There we have, I hope you can see the mouse pointer there. I'm using that to highlight some spots I'll be talking about. I'm trying to show short examples that fit on one page, so I'll show just bits and pieces. Some of the examples you have to imagine in a larger context of a big project where they make much more sense than in the way you see them right here, but they're supposed to give you the idea. So what we have here is very normal PHP thing where we have an action that's passed in by a request. There's probably a get or a post, some link the user has clicked on, and if the action is add, then we'll fetch something from a database, we'll count it, and then we'll update the quantity of whatever item this whole thing is about in the database. And then there's also remove, where we'll fetch something from the database and then decrease the quantity and then remove that thing by just reducing the quantity. This is very normal code. I think in a real project this may be spread out over different pages, whatever. Just to give you the idea, let's look at that thing and see if we can spot some redundant code. Well, I can. Look at this. We have 2 select statements there, and they are exactly the same. Actually, we have 2 blocks of code, and they are exactly the same. This is a very, very normal thing. If you create the application and you put in the add command, and at another point you put in the remove command, you just copy and paste, and this is what you usually end up with. And if you continue copy and pasting, then you'll end up with like 20 copies of that. When the database structure changes, you'll have to change your code in 20 places, which is a bad idea. So what can we do about that? Let's create a function. We call the function getQuantity, and we pass in one item. So we get the quantity of one item. We'll have to connect to the database here. I'm using an SQLite database. This is just so that I have examples that are work without an installed database server. Don't worry whether if you don't use SQLite. It's not really the point which database we're using here, just to show the example. If I wouldn't be using SQLite here, then I would have to pass in a database connection from somewhere else, which would just make the thing more complicated. So for demonstration purposes, I try to keep that as simple as possible. So then this is the select statement. Basically, we copy and pasted that from above, and we'll get back a result, and we'll return the first element from the result, which is going to be the quantity. And so this is it. And we have replaced the duplicate code by one function. Can we spot more duplicate code? I can. There's an update statement, which again is exactly the same. Sometimes it's not exactly the same, but only similar. No problem. You can always add another parameter to the function you're creating and still get away with creating a central function. So let's create a function here to update the quantity. We'll pass in an item and a quantity. We'll connect to the database and then execute the statements. You will realize that there is no error handling whatsoever in all these examples. As I said, they are just examples, not real-world code. They are derived from real-world code, but it's not production code that I'm showing here. It wouldn't fit on the one page if I added all this error handling. So I just cut down to the most important thing. Okay. So let's have a look at what we got. This is simplified refactored program where we have replaced the duplicate code by function calls. Now let's compare that with the original code. I think the animations are really crappy over that connection. So I took out all of them except like 2 or 3 spots where I had to leave them in. So this is the original code here on the right. And as you can tell, this is much longer and this is much more complicated. This is not as easy to read, and I prefer this one very much. And it also has the advantage that all the select and the update statements are centrally in one function, and I can change that function. So I change a select or the update in one spot without touching anything else. And another advantage I have here, this is something we'll come back to later. If I look at this code, it's rather easy to read. I can immediately tell what is happening, but I don't have to worry about any details of database, data access, or whatever. And as you can tell, I didn't put get quantity from database or something in here because it needn't be a database. I can also get the data from a flat file, from XML, from a web service, from anywhere else. And I would just have to adjust my get quantity and my update quantity methods without touching this piece of program, which is a very good thing. All right, another example. It's a very typical thing, especially if you look at older PHP applications that started off by putting a little PHP into HTML pages, and a lot of that stuff still exists out there today. I keep seeing it all the time, and I have some suggestions how you can make that better. What we have here is a form, and this is an incomplete example. As you can tell, there's no table end tag. This is just to illustrate the purpose again. If I look at that, I see very similar code 3 times. It's not the same code now. It used to be the same code in the previous example. In this example, it's not the same code, but it's very similar, and we could make it the same function by parameterizing it. So let's do that. We'll create a get input function. We pass that the name and the value, and this function will return the HTML tag that we need, and we'll just stick a print and a call to get input in here those 3 times. Now, why I create the function to return a string instead of printing it is very easy. If I return a string, it's much easier to test the whole application. When I want to test if that is a valid HTML tag, I can just call the function, work with the string I get back, and look at the string, except for can look at the string and I don't have to parse the HTML output of the whole thing. So this is one move towards unit testing, which, as I mentioned 2 weeks ago, as you may remember, is a very important part of refactoring originally. In reality, it's very tough to introduce unit testing to very procedural code that we find often in older PHP applications. So for the examples I show here, I won't show any unit testing and any testing. I just want to mention this doesn't mean that I think testing is obsolete. Rather the opposite. It's very important, but if you don't have the tests and if you do those easy refactorings that I'm showing here, I think you can get away without testing. Okay, we have a question there. So question is for get input value, isn't that adding a lot of overhead, particularly for PHP to call a function 3 times in the output result instead of just outputting the value? And basically you are right, and a very good question. Yes, it is an overhead because you're computing it instead of just outputting it, just pushing it through the web server to the client. But in my opinion, developer time is worth more than computing time. And PHP is very fast as long as you don't do a lot of I/O and database access. PHP is usually very, very fast, and calling that function 3 times does make it a little slower, but it's less than a millisecond probably. The advantage that you gain from it is if you want to add, say, a CSS class, you can do that in that one spot by putting it here, and you have it in all those tags. If you don't use the function, you have to change every single tag in your application and add the CSS class or whatever 3 times, and you can imagine in a real application there are way more than 3 input tags in there. So I think the idea is add some computing overhead, but it's less than a millisecond, I can promise you, and you can benchmark it. It's virtually no difference if you would benchmark those 2 program versions, but save a lot of developer time. Okay, so thanks for that question. I hope that was answered sufficiently. What have you got? We have got 3 blocks of, well, very similar structured code. I don't like that. We should do something about this, I think. So let's create a function. Again, I have a function getFormRow, which outputs or which creates one table row with a label and a field. And the trick is that I call a getInput function here and pass in the result as a string. So basically I can put any form field I want into that form row, and I have the 3 statements printing the form row here, which leaves us for now with this code. It's still not perfect. We'll get back to that example later, and I'll show you some more interesting refactorings based on that example, which I think will also show you why it does make sense to programmatically create forms instead of hard coding them in HTML. Which takes us to the next step, shorten code blocks. And I don't really have too many code examples to show with that, because there is no point in showing you very, very long code, breaking that down into 2 or 3 functions and then showing you, it just would be too small to read. So you know what I'm talking about. The idea is break down the code into little pieces. Basically, that's the essence of the whole thing. That's the essence of object orientation also. Break down your application code into lots and lots of little pieces of code. So if you want to change one, you don't have to touch the rest of the code. And if this code is in modules, and they are as independent from each other as you can make them, it gets very easy to change code in one spot, in one module, in one function if you want, without affecting the environment and the rest of the application. You'll see that in another example that's coming up later. So, in my school of programming, a method or function should fit on the screen without scrolling, and my eyes are not too good, so I don't really use a small font in my IDE or in my editor. I just make the functions and the methods really small. If they get bigger, break them down into different ones. I'll give you some tools on how to do that later. When code needs too many inline comments, that's another good sign that a code block is too long, because if you don't a good idea of what's going on, then and you want to clarify that by putting in the comments, it might be a better idea to break down the code into pieces, to create a function, to use a speaking name for that function that tells the developer this function does what its name suggests. And I would suggest never using more than 3 nesting levels in your code. That's 3 nested loops, 3 nested ifs, or whatever. Some people might argue it's not possible to write a lot of programs because you'd need more than 3 nesting levels. I think you don't if you break it down into functions, number 1. And number 2 is a very common error to build a function and you put in nested ifs, like if the first parameter is an integer, if the second parameter is a float, if the third parameter is a string, and if the third parameter string is a valid email address, and if the mx lookup for that email address is okay, then I'll do something. So you have like 5 nesting levels, and this makes the code really hard to read. What I would write instead is, if the first parameter is not an integer, then throw an exception or die or aspect false, whatever means of error handling you want to use. If the second parameter is not a float, then throw an exception, and so on. And this needs no nesting level at all. You have the if, and you go back, and then it's much easier to read because you don't have to use all these indents, and you'll have the thing that you have all the error handling up front, and then you sort of have, if everything went fine, this is what I'm doing here. We have a comment from the audience here. Deeper nesting also slows down processing. This is definitely true. If we're talking about loops, because for every loop we need stack space, and deep nesting can actually make you run out of stack space in the end. And creating a stack level, working with that, and then destroying it, obviously takes some work, which again is just a matter of milliseconds, but definitely true. The comment as it is slower, right? Oops, sorry, or n for n loop. Obviously, if you iterate over n elements. Thanks for mentioning that. Okay, let's continue with my basic rule of code length. It's the 30-second rule, and I have to admit that I have invented it for myself, and somebody else had already invented that before me. So I don't claim that I have invented it, but I came up with it for myself. It's also published on the internet somewhere else if you go searching for that, I think. And it says, if you don't understand a function or a method after looking at the code for 30 seconds, you'll need to refactor. You'll need to break it down. It's too long. It's too complex. I don't want to write a long comment explaining what the thing does. If you cannot tell what it does by looking at it for 30 seconds, it has to go. This may seem a little over the top, but I find that when you're programming, it's very hard to sort of dig down into all the details of the code. You need to gain a basic understanding of what the code does. If you work on some level of code, you don't want to deal with all the other levels. Like if you work on the business logic, you don't want to deal with all those details of data access, as we have seen in the previous example, if you recall. So whenever you don't understand the code, it's time to refactor, change it, break it down into pieces. It's very easy to write code that let's say it's rather easy to write code that a computer can execute. The code is also to be read by humans, and humans will read it more often than write it. Take some time, look at code that you've written 1 or 2 years ago, and look at the most complex code you've ever written and try to figure out what it does. You will probably have a hard time if it gets into the details. So make it really easy for you and your colleagues to read and understand the code. If you need a lot of comments, then probably something's wrong, and you might want to consider breaking it down and using good naming scheme, as we have been talking about 2 weeks ago. The next step is the most important step. Separate different concerns. We all have heard of the 3-tier architecture, which is the basic software architecture that came up with the client-server software model in the 80s, I think. We have a presentation layer, we have a business logic, and we have a data access layer. Presentation layer handles, as the name suggests, the presentation issues. Basically, this is where the HTML is. The business logic does the heavy lifting. The business logic does all the calculations. The business logic is where the action is. That's basically what your customers pay you for, and this is what the management pays you for. The program has to do some stuff that's useful to your company. And then we have the data access layer, which is whatever you are using, database, XML files, flat files, S3 storage, which seems to be quite common, or become quite common right now. Wherever you put your data, your application should not worry about. And this is why those layers are separate. And this is very important to clearly separate these layers. And I'll show you how to do that in a later example. Separate different concerns to me also means separate functionality of the application, separate the different commands that your application processes, separate adding stuff, removing stuff, modifying stuff. It's also very important to present that in a sane way through the user through the GUI. You don't want the user click somewhere to delete the whole database without ever being warned or asked that that he might potentially do something bad when he clicks OK now. And it's the same in code. You shouldn't put like very critical code that kills all data in your database near code that just adds some harmless values. I would recommend trying to split that up. So we have a question coming up here. Is this design also known as model view controller? Model view controller is a pattern, a design pattern. Not really. The 3-tier does not refer to model view controller. Model view controller basically is separating a business. Yeah, basically it corresponds to the 3-tier architecture is a layer model. A model view controller is it's not always possible to clearly separate the layers, but the basic idea behind it is the same. Use model view controller to separate different concerns. I should have put that up on the slide actually. But I promise you I don't talk about OOP, so that's the reason there. Do also separate input and input pre-processing. We have the filter extension is rather new in PHP now, and it allows you to centrally filter the data that's incoming to the application, which is a very good thing to make your application more secure and less prone to XSS and CSRF and whatever attacks. This is a good thing to do, and I would always recommend doing the input pre-processing and input processing in one spot of the application. I'll show you an example for that later. Okay, one basic rule of thumb: no SQL near HTML. This sort of sums it up. If you have SQL near HTML, you mix up data access with presentation, which is definitely a bad thing because there should be business logic in between. But the traditional approach of sticking some PHP into HTML pages is exactly putting SQL near HTML, and this is the thing you should avoid. Okay, if you really separate different concerns, you make unit testing possible, because your application logic suddenly becomes decoupled from the data source and from the presentation. which means you can test the logic without worrying about the database, and you can test the logic without worrying about presentation, which means you don't have to parse HTML tables to figure out where the correct data is. You can just call a method or call a function and look at the result using a unit test, of course. This allows for much more code reuse, and that much should be bold and capitalized, because it's really what makes the difference. Code reuse is not going to happen if you don't separate concerns. Separating concerns, by the way, is also about separating things that are specific to your application from things that can be used in a general sense. So that would maybe go into framework. Code also becomes easier to read because you can focus on one aspect. If you think of the example I've shown you before, we had all this database access code in functions, and if you look at them, you focus on the database aspect, and you don't need to worry about the business logic, because the question is, where does the data come from? Where does the data go? How does the database structure look like? But if you look at the business logic level, you don't want to worry about the aspect of the database. And this makes code easier to read because you add more abstraction. You don't worry about the data access if you look at the business logic. That's what it boils down to. Let's look at some code again. This is a little more complex example for, I think, very typical PHP code as well. It's incomplete again because it just wouldn't fit on the screen otherwise. We have a database connection. We assume there already exists a database connection. We'll get some data from the database in a certain order, and I'm well aware of the fact that this, as it stands here, would allow for SQL injection attacks. But again, this is not a security session here. I'll just illustrate the purpose. This is not a production code. We don't worry about error handling. We don't worry about security here. This is a clean and safe environment. So there we'll create some HTML stuff. Then we will loop over the database result, fetch a row, put out a database table row, and then put out sort of the footer of the database. No, actually that's another column of the table where you have action links that you can click on to add another item or remove an item or whatever. And this ends the HTML table. So let's think about separating concerns here. What have we got? Number one, we have presentation. That's the stuff I've highlighted there. There's a lot of presentation there. There's a lot of HTML code. And as you can clearly tell here, this is a violation of one of the rules I said before. We have SQL code right next to HTML code, which obviously is not a good idea. We even have some business logic in there. Admittedly, it's not much, but again, it's just a short example to illustrate the purpose. This could be a way more complex calculation if you want. What we're doing here is we are creating a grand total of the values of a number of items in this example. And we also have data access there. It's the code that I'm highlighting right now. That's the SQL statement, and that's the looping over the database result until there are no more rows in the result. So let's break that down. Let's separate the concerns, and we're going to start with the data access. It's probably the best idea to always start with the data access if you want to separate the concerns, because once you have the data access separated out, you'll see that things immediately become clearer and easier to understand, and this allows you to change other stuff much easier. So even if your primary focus is not on reworking the data access, you might take the time to factor out the data access. So what we're doing here is we're creating a function getData, and we pass in a sort order. We have to connect to the database. That's something that wasn't shown on the previous screen, but we'll obviously have to do it here, because otherwise the DB object we're using here, a little object orientation has to be in there. So the object here would not be valid otherwise, and I don't want to pass the object around. For SQLite, it's not a problem because it's basically a database that's in one file or even held in memory, and it doesn't have a database server like MySQL or others have. So we're selecting the data, and we'll create an empty array, and then we loop over the database result and just create associative array, put that into result array, and pass that back. This is not much happening. We could add more here, and we could also come up with a completely different way of representing the data, not just using the associative array that's passed back from the database, but we could come up with something else. Or, as you have guessed by now, we could replace the database by a flat file, or by an XML data structure, by some JSON, by a result we get from a remote service call, whatever. It wouldn't affect the rest of the application as long as we stick to the format that we have agreed on here. So what we're doing here is we're defining an interface. And how do we use that? For each loop over the result of get data, and the R is the same that I've used before. I personally don't like the name. That's another thing that I would change in that code. I would call that row or item or whatever, which I think makes it clearer. But well, let's leave it there for the time being. Basically, that's step number 2. Consistent naming scheme. You should change the name here, and then we do another loop over the table columns if you want, and there is some stuff we do here. The first value that we get back is the ID of the identifier of an element, and we are going to use that along with those action links here. That's why we pull it out there. I could have done it without a loop, but I wanted to write it as a loop, so that's why I distinguish. And the first thing is going to be the item ID. This should be ID, actually. There's another example for having a not so good name. All right, let's move on. And let's see what we can do about the business logic. I want to pull out the business logic. And this is a solution that one can argue whether it's a good solution. But it's just one possible solution I like to show here. I create a function getTotal, which does another database call, which asks the database to sum up the quantities. The idea is that the database is better at doing calculations on the data because it's optimized for that, and we don't have to transfer data to count the number of elements in PHP and then output it, but let's just let the database count it. And that way we can output the total by just calling getTotal function, and we don't have to fetch all data, which was not possible in the way the application was written before, but it's possible now. On the other hand, I do agree that it's another database call that maybe should be avoided. If you want to create a high-performance application, you probably not want to go with a select sum here, but you probably want to pre-calculate the sum, put that into another database table somewhere, and then just do the select there. So you would have to update the sum whenever you change something in the database, which puts you at a certain risk of doing things wrong and forgetting to update that, getting inconsistent data. So there's a pro and a con to that as well. But that's just as a side note here. So this is how we get it in there. Instead of summing it up and outputting the sum here, we just put a call to the getTotal function in here. Great. So basically, this leaves us with all presentation here. This is just the HTML stuff. We'll loop over the data. We'll output database table rows and database table columns, and then we'll enter table, and that's it. We have the data access and the business logic separated out, which is very cool, because now we can do one of the following if you want. We can create another function. This one is what we already have, to create the good old HTML table that you've seen there. But we could substitute that by a call create fancy Ajax user interface that would create a table with the most fancy Ajax effects with in-place editing, whatever you can imagine. And you just pass in the data and the total. If you want that displayed, you could even leave that out here, and it's going to do it for you. And you don't have to touch the data access, you don't have to touch the business logic, it's just substituting one call, changing the user interface, which is absolutely cool, I think. You could also go with something like export the data to whatever special format, because yeah, that's the data, you get it from the database in a defined format. That's the interface we have agreed on before. You can define the interface in a way as you like, but I would recommend sticking with the simplest thing that could possibly work. There's another good rule of programming: stick with the simplest thing that could possibly work. And if it comes as an associative array from the database, just use that and work with it. It's always a good idea. So let's get back to that example I showed you before. And I want to show you how we can make that even better by actually separating more concerns. We have very similar rows here, the get form row, and the question was already asked, is it worth putting in that, substituting plain HTML code by function calls? Well, yes, I think it's worth it. I'll show you in a second how we can further refactor this code to something which is really nice. I'll create the function create form body, and I pass in form rows. We get to that in a minute. I loop over the form rows, and each row I will output one form row. This is the same function call you've seen before, and each row element obviously is an array with two elements. So let's have a look at how that looks like when we apply it to the code. We'll define a data structure with a label, and this is the HTML code of the input. So this is a string, and we put in three arrays in this form rows array, and this defines our form. And then we create form body call. This again gives us back a string which we can easily look at and analyze if we're testing, or we just print it out if we want to send it back to the browser. So the advantage of this solution is we have sort of what form fields there are is separated, and we can very easily add another form field here by just adding another array element. And this is something you would have to create an if statement, another if statement, and another potential nesting level in your code. I think this is a much easier and much clearer way of doing it. So that leaves us with the question, what are we going to do about this stuff up here? There's still plain HTML code there. What I'm going to do about that is I'll create a create form function. I'll stick to the form rows as we used them before and pass them in, and the create form function looks like this. I pass in the name and the form body. The form body actually is these form rows, this data structure here, and I just output the sort of add the static HTML I had in the last example. I add that here to the result, and then whatever else I would have to put in the form, and I call create form body. So based on the create form body function, I add on to this, add stuff around, create form. So I have a function that creates forms, and I could even explore that further and create a form, create a page, whatever you want, if your application needs it. This is a very good way of sort of moving from static HTML to a very, very dynamic way of working with an application, because now you can, just by changing data that you input, you can create a different form, which is much easier than actually editing the static HTML. So this is how the thing looks. Print create form, and this is named contact forms, and we'll pass in the form rows. Great thing. I like that very much. I would not recommend you to actually do it that way, or to put it another way, I wouldn't stop there. I would go and make that object oriented now. I would actually create a form object, and I would pass in elements with a label and an input, and build the form, and then define a renderer that allows me to display the form. And by changing the renderer, you can display the form in a completely different way without changing the form itself, changing what fields there are, what labels they have. This is sort of the business logic of the form, and then there's the presentation, which is how does it look like? Where do I put the fields? Which color do they have? Where are the labels? Is it right aligned, left aligned, whatever? How does the whole thing look like? You can separate that. It's not shown in this example, obviously, but you could do it. And a lot of the form classes that are available out there, if you look at Peer, if you look at the Zen framework, I think they have a form class coming up. They use these approaches. So if you understand this example, you have all it takes to use one of these form classes, and you're really going to benefit from that. And always keep in mind the essence is separating those different concerns and making your application very dynamic. Instead of editing code, edit the data and use the data to dynamically create stuff. That's why it's called a dynamic language, I think. And this is one of the essences of PHP to me. So to another example. This is something you've seen before. Let's explore a little more on this example, and you're going to see a great thing about input processing there. We have 4 axes of this super global request variable. Personally, I do not recommend using request super global at all, because it's very easy to put some value into a cookie. And the cookie value actually overrides get and post values in the request super global. So you could easily fake someone into having a cookie on his computer with a fake username, which would effectively disallow him to log into your application. And there are some naughty things I could imagine doing, exploiting that further, I think. But again, this is just to illustrate the purpose. I think a lot of applications have these super global or even those old long arrays or whatever to access the incoming data. And what I'm ultimately going to show you is how to centralize that into input, into central input processing, if you will. So what we're doing is we'll put up this item, and I'm using a local variable here. Probably this whole thing would be into a function, in a function, so I wouldn't want to make that a global variable. I don't like global variables, but again, just to illustrate the purpose. And we have to check whether that input, that key is actually set in the request super global, and if not, then we'll use the empty string. That's just to avoid error messages. If we assign it here and it has no value set, then PHP is going to complain with a notice, I think, and I want to avoid that. You always should write your code so that no warnings and notices appear. So we'll just substitute the item here, and I think it makes the code way more readable. And well, there's the action thing left. And yeah, basically we do the same about that. We'll define an action local variable here, and we substitute the variables here. So the advantage of that is that all the input stuff I'm processing, I have at the top of the script. And it's very easy for me to look at that and to gain an overview. Okay, what input data am I actually working with? And then it's just local variables, and I could modify them. And I could say, okay, the action is maybe is an ID, and I'll substitute that by a string or whatever transformations you wanted to apply there. Okay. Now this thing actually turns out to be obsolete. In the old version, we needed that to prevent potential error messages when we compare with an array key of request superglobal array which was not set. Since this cannot happen anymore, because we already provide a fallback value here, we can get rid of that. And again, one nesting level is gone, which is a good thing. And this is much easier to read. Again, what I like very much about that piece of code is that I have all the input stuff at the top. But now let's look at that again. Do we spot some redundant and similar code there? Well, I do. Let's do something about that. I create a function getInput, and I pass in a parameter which actually is the name of the key in the request superglobal array, and I'll perform my check. If it's not set, I'll return an empty string, and otherwise I'll return the value in the superglobal request array, which makes very nice code, I think. I call the getInput there, which immediately tells me, okay, this is an input variable. This comes from the outside. I should not trust it. I should validate that, and then I work with it. You could argue over using this local variable or put in the getInput instead of the item and the action local variables here. Again, this is something you can argue about. I think it depends on whether you and how many instances you used that and how your code actually looks like. It's definitely something you can do either way. Usually, it's not a good idea to define those local variables just for the sake of defining them. But if it's for input data, then I know item is a local variable that holds input. And if I want to do pre-processing to the input, and if I want to make sure the input is sane, then I can stick that into the getInput function, which is a good central way of doing it. This is what I mentioned before. Put all the input processing in one central place. I would actually prefer using a class for it. If you want to go with a function, no problem, but do use a central function. The big advantage of this solution is all you have to change is getInput, and you can test your program with input that you fake up and do not pass in by request, so you don't have to use a web server and send a get request to your PHP script, but you can just create in a couple of lines PHP, come up with an array with the input values that you actually need to fake and pass them in, run something and test your application. So this decouples your application from the user interface. There we again separate the concerns. Definitely very, very good thing. So last step, number 7. Again, there's to compare that. I think it's not much shorter, but I think it's much more readable. And I don't like all those requests scattered through the code, because again, if I want to change that and simulate input, I'll have to change it everywhere. If you want to replace request by get or post, because as I said, it's more secure. It's much easier to do that in one central spot in the getInput function than to do it all the code in every occurrence of the code. Okay, so one last step, number 7, replace implementations. There's the plural S missing there, I just realized. I'm sorry about that. I'm going to fix that before I post it. There's different ways of doing that. You can use a native PHP code instead of an old extension. You have PHP 4, for example, you use an old extension that's not maintained anymore. You might want to replace whatever you're using that extension for by native PHP code. Or the other way around, you might want to replace native PHP code by an extension, because an extension is in C and it's usually much faster than userland PHP code. You might want to use components like pair, like the Zen framework, which today, of course, is the most important framework. Tomorrow, I also like easy components, but today I'm all in for the Zen framework. You have something in your code that you come up with years ago because no component that would do it was there, and now there is a component. Then refactor your code to use that, because you'll delegate maintenance of a piece of code to somebody else, and somebody else has program that has thought about the API, has tested it, and this is work that you don't have to do, which is a very good thing. And then have a look at PHP, have a look at the latest version of PHP. There are a lot of extensions that are new in various versions of PHP 5. For example, XML Writer, which allows you to programmatically create XML. The advantage of this is that you don't, it's not possible to end up with invalid XML because the application creates it for you. There is a native SOAP interface, which used to be a problem. There was a rather crappy SOAP implementation in PHP, and now there is a native extension that's very fast and that you can use. This is a very good thing. So replace implementations, and this also means rewrite ugly code. If you have a code in your application that is ugly, that is buggy, that is absolutely not understandable, then just rewrite it. Have a look at what it does, and then reprogram that from scratch. But do that to one function or method, and not to the whole application. And that's the key. That's the essence of it. If you don't rely on global variables in your code, and you shouldn't, because global variables are evil because they make you depend on all those global variables, and you can never control whether anybody is going to modify them. If you don't rely on the global variables, changing one function or one method, if you're an OOP guy, if you change one class, it doesn't affect the rest of the application. And this is something that's really very, very cool. You can change something in one spot, and your application is going to benefit from that, but you don't have to touch and change the rest of the application. So, just to sum it up, these were my 7 steps to better PHP code. Number 1, format source code consistently. Use consistent naming. Look at the slides that are up at the URL I put up on the slide before. Document the API. Use PHP Documenter. And the 4 steps that actually deal with the code that we've covered today: eliminate redundant code, shorten the code blocks, separate different concerns, and replace implementations if you need. And if you do that, you don't have to apply those steps in sequence. And if you look at the examples again, you'll see that a lot of the examples, they actually apply to more than one of the steps. So eliminating redundant code also can mean separating different concerns, as we did in the first example when we factored out the SQL access code. So you don't have to even distinguish between those steps. It's not really important. Those are just the guidelines that how you should look at your code, what is where you should start in changing things to make your code better. So that's it for the presentation part. The slides will be made available at the given URL. The audio and the slides of the first part, I mentioned that often enough today, I think, are already online. You are more than welcome to drop me an email. I will be at several conferences this year in PHP Quebec. I think I will be in PHP Tech in Chicago. So if you show up there, I'll probably be in a German PHP conference in fall. Maybe I'll make it to ZenCon, depending on whether I bribe them to accept my talks. But I would be enjoying to see you there, or see you in another upcoming webinar. I wish you all a nice day. It's 7 p.m. over here. I can have a beer and call it a day now, and I wish all of you a nice day of work or a good night wherever you are. Try out some refactoring today. Have a look at the Zend IDE. I think it's a nice start for some refactoring. And well, if you have any questions, then I'll be happy to answer them. What's your method to organize these helper functions? One large file or each in a separate file? That's a very good question. Whoever you ask is going to tell you something different. I would start off with one file just to keep things simple, and then I'd spread off. I'd separate them in different files if it gets too large. But having them in different files just makes maintenance easier. And the real benefit is if you load the files selectively. So if you don't load all files, but just those that you need. And with library functions, there's always a problem that you never know ahead which ones you're exactly going to need. So for a library, you're usually load all of them. If you use a bytecode cache, that's another story again, but for stock PHP, the best idea probably is to benchmark which version is better in your environment, because the results really differ greatly. Okay, there is a problem with the audio at 1833. I hope that you will be able to catch up. Is there a reason to compare the value to the variable as opposed to comparing the variable to the value? Yes, there is a reason. If I accidentally write only one equal sign, then I'm going to get an error because I cannot assign to a string. If I put it the other way around and you write one equal sign, then PHP assigns the value and doesn't tell you that you've made an error. What do I think of the Symfony framework? I like Symfony very much, though I don't like using Symfony in my projects, just because I don't want to be locked into a certain way of doing things. So I'm not the framework type of guy, but this is just my personal preference. I think Symfony is a very good thing, and Fabien is doing an excellent job. Dustin Whittle also, they are doing excellent jobs. They are very nice guys. Symfony is definitely something you should have a look at if you hadn't already, but it has a learning curve, so it's going to take you some time until you get things done, and you need to have a basic understanding of the whole framework, whereas PHP usually lets you start quickly and have more instant results. Okay, there was a question if the action should be a switch. Yeah, you could do a switch for two actions. I'm not sure if that justifies a switch, and I actually don't think that using a switch would make a real difference in the performance. Using a switch, I would use a switch to if I combine that with selectively loading the code. So if you just load the code for that one command, but honestly, if that's just 3 or 4 lines of code, you're probably going to waste more time on the disk access than to just stick all those functions into one file and loading that at once. But again, that very much depends on how your application looks like. So, any more questions? Do I need to scroll somewhere? Let's see. Okay, you'll probably all have that in the chat window. The next version of Studio for Eclipse will include extract function variable method, which basically is functionality to help you with creating a helper function, as I've shown you before. And I'm very eager to see that and to try it out. Actually, that sounds like a very good feature. Any more questions? Okay, so if there are no more questions, I think we'll call it a day. Thanks everybody for tuning in and listening. I hope to see you soon at one of the conferences. Watch out for stuff that I write. I have a series of Xdebug articles running on DevZone currently, and I think I'll have 3 books coming out this year, so this is probably going to be a very interesting year. So there's another question: is there any way for thread-based programming in PHP? No, it doesn't really make sense in PHP. I think it makes much sense at the operating system level. So the question is whether to run Apache and PHP threaded, multi-threaded or not. But in PHP, I don't think it doesn't make sense, because the philosophy of PHP is to start one process for each request that it's processing. And I don't think I can't see how threading would fit in there. If you can come up with a clever idea, feel free to suggest that to the PHP developers and mailing list. But I think to this day nobody has really come up with a use case where it would be absolutely beneficial to have threading in PHP, and it definitely would be something completely different from the PHP we know today. So I don't think it doesn't really fit in. It doesn't really fit in the model, in the PHP overall model. All right. Anything else? Okay, just drop me a note if any questions turn up. Thanks again for tuning in. I think we'll call it a day.